Okay, so today we're going to be going over a no backlight board. It's a Macbook Air. And I want to go over a little bit of how you can kind of figure out where the fault may lie. So one of the things I like to do is I like to take the multimeter, put it in diode mode, put red probe on ground, and put black probe on backlight output. And over here I get 0.572. Now on a working board that has backlight, I usually get 0.519 to 0.546 when it's an LP 8550 based board. What I mean by LP 8550 based is that the backlight circuitry is based on the LP 8550 chipset. So if I were to move over to the schematic over here after I close out of all the personal stuff I don't want you seeing on my monitor, you're going to see this. So this is what I mean when I say LP 8550 based. This is the LCD backlight driver, and when I zoom in, okay, I guess Adobe just doesn't want me to zoom in today, so whatever. It says LP 8550. I know YouTube probably sodomizes it, so you probably can't see that. I don't know why my PDF reader is not allowing me to zoom today, and I'm just too tired to fight it and find out why. Yeah, no clue. But yeah, this is an LP 8550 base board, and that's what I have. So first thing I'm going to do is run it through the ultrasonic cleaner. This board came from a place I've been telling them to buy an ultrasonic cleaner for the past year and a half. They have not. And this is the LED driver, which looks just fine, but right next to the LED driver, you have some of that. So I'm pretty sure that this was liquid damaged. And before I even bother replacing stuff, I'm going to make sure that it's cleaned off. So we toss it in the machine. And we'll go from there and see what we get. All right, so this has been run through the ultrasonic cleaner, and now that it was run through the ultrasonic, we are going to get to work. So that did not fix the no backlight issue. It still has no backlight on the LCD. And my diode mode measurement, instead of being what it was supposed to be, which is between 0.519 and 0.546, I had something like, I think, 0.561. Let's just double check and see if that's still the case. 0.574. So here's the cool part about diode mode measurements. And, it's like a resistance measurement when it comes to checking resistances in a circuit to ground, but instead of taking forever, it just happens like that. It's like ding. And what you can start doing is you can start associating certain numbers with certain problems. So for example, I know to associate if the feedback via is blown. So let me just bring up the schematic here so that I could show you what it is I'm talking about. Look at that. My PDF reader will let me zoom in again. Never mind. Spoke too soon. So for example, I've noticed that if this is blown from D7701 to the feedback pin of the LP8550, that my measurement is going to be something like 0.453 to 0.511. I've noticed that if the switch part is broken, so from here to here is broken, that my measurement is going to be something like 0.550 to 0.6. If I've noticed that if this chip is internally broken and shorted to ground completely, that I'll have a 0.001 or 0.007, or if the LCD connector has a short inside of it. If it's 0.256 or something like that, then I also know that it's the LP8550. And the way I know this is because every single time I have a problem, I measure it using the diode mode measurements. And what I do is I make an association in my head with whatever it is that I found. So again, feedback. So when I see, feedback via is not working, before I'll actually fix it, I'll measure it, and then I'll have that in my head so that for the next time when I start troubleshooting a circuit that has an issue, I can just measure it and, just get a general idea what it is I have to do. So here I'm pretty sure that the switch portion of the chip is bad. You're not going to be reusing that chip anyway. So what we do here, turn on the fume extractor, since again, I don't want to get myself any horrible diseases from inhaling solder all day. I'm going to get my spool of chips, because as I tell you, you should always stock things that you're going to use regularly. And you do need to stock this stuff. Love still being sick. And we're going to get started. So hopefully my microscope setup is working. Come on. There we go. And we're going to replace this little thing. I wonder if those like marks on it, is that actual dirt? Because I've compressed aired that stuff out before. Is that actual dirt or is that just like permanent scratches? I guess I'll find out later. One of these days I'll get around to cleaning in the inside of the trinocular port of the microscope. Look, a little solder ball. Now, I shouldn't have used that tip to begin with. That's not really the right one. I'm going to use this flat tip over here to do the wicking. Did anybody ask you to beep? Did anybody ask if you could beep? Anybody say it was okay for you to beep? If you beep even one more time, if you try to beep even one more effing time, oh, you're going to get it. You are going to fucking get it. You are going to. So Hackle makes some annoying products sometimes. Sharky never beeps. Zhaomao doesn't beep. That looks like crud. You're going to use the most professional cleaning tool there is, which is the end of my index finger, a cheap Amazon.com paper towel, and some alcohol. Oh, yeah. That's how you do it. Oh, I can't wait to see the trolls that I get on this one. People are going to fucking scream, I can't believe he used a paper towel on the end of his finger and he know that there's no ESD protection. You could be knocking off the resistors. Oh my god, how unprofessional. Fuck you. You know what professional is? It got here 10 minutes ago. It'll be fixed 10 minutes from now, and it'll never be back. That's professional. Really. When you know what you're doing, you can do things the way you want. When you don't know what you're doing, it doesn't matter if you follow a guide or a manual. It will all come out super fucked up. I know. I've been there. Okay, so what's this talking about over here? I'm not really happy with that. Open the board that this is. This is a 3437. Oh, you're ground. I don't care about that. You'll be fine. Oh, you see, you got ground over there already. Why am I even driving myself nuts over nothing? Alrighty. Now we're gonna put flux. Oh my, that's too much flux. Oh no, it's not gonna work now. No! Ugh. Okay, get the flux on the balls, get the flux on the board, make sure it's all nice and fluxy, fluxity, fluxed. And for the soldering time, so I had my hot air station a little lower, so that'll be enough to blow away the excess flux so that I can see stuff. And by the time it heats up, I'll be ready to solder my chip because the excess flux will be blown away. Now, once it melts into place, it's going to be like kind of moving back and forth. That's what I'm looking for. That's what I was looking for back when my hot air station actually worked and wasn't a piece of shit. Let's see if that melted. I can't trust. That's the thing. When your tools suck, you can't trust them anymore. I used to just trust it. I saw it move back and forth. Oh, that ain't melted for shit. Oh, that's awful. I may just go on and buy myself one of those Pace or Weller ones today because I can't deal with this whole hot air station being a piece of shit thing. All right. This is, by the way, this is supposed to be an easy fucking job. It really is. Like this is a great example of why you don't buy crap tools. So even though this is not a crap tool, this is an expensive Hacko tool. It's working like an IOE right now. So this is what happens when you buy IOE. So remember how I said it's just supposed to start moving back and forth, and that's how you'll know that you're good? It never started moving back and forth because it never heated up enough. Here you go. So see, it kind of moved into place there. And when I move the iron back and forth, you can see the chip dancing. You see how the chip is kind of dancing? That's how you know that the balls are liquidous. You want the balls to be liquidous for a decent amount of time because almost all the balls can be liquidous, but the center balls that are hard to get to cannot be liquidous. And if they're not liquidous, then you didn't really do anything. See, that's the way they're supposed to look. So you got to see what it's like to solder with an IOE station, and then you got to see what it's like to solder with a Hacko station, even though this is not acting like a Hacko. You know, one of the points that I keep trying to get across in this channel, I don't want to just show you how to do the work right. I want to show you how it gets done wrong so that you know what to avoid. Because that's something that I really wish had happened with me. Because, like, you know, I don't need to just know how to do it right. I need to know what's wrong. I need to know what to avoid doing just as much as I need to know what I should be doing. Nobody really points that stuff out. Because they're kind of afraid to. Like everybody just kind of thinks that you should just look like you're a genius and everything goes perfectly all the time. And how dare we be unprofessional and show something that isn't absolutely perfect? I don't give a fuck if somebody trolls and is like you're unprofessional or that's not perfect or blah blah blah. Well, like everything you do, it comes out fucking perfect. Like your tools work 100% all the time. Like you have all the time in the world. Like you've never made a mistake. No, you're human. Just like me. I'm sorry to tell you. You are. You are. You make mistakes. Your day doesn't always go perfectly. Your boards don't always come out working. You sometimes have to go back in because you thought it was one thing and it wound up being another. You get bad chipsets in the mail and the DHL just like I do. Like, you know. You're all human. Just like me. And this channel is meant for humans. Not for little like robots and brainiacs and This channel is for regular people that want to learn something. I might as well check my diode mode measurement with the new chip. It's going to be a little fucked up because the chip's never had any power run through it before. So let's see what I get. 0.514. So I said that I'm used to it being between 0.519 and 0.546. 0.514 is much closer to that than 0.572 and 0.6 like I was getting before. The next video I do, you'll most likely see a new hot air station on my desk. Because by then I will probably have tossed that FR801 out a window. That's the proper burial for it. I mean, really, the thing has given me about... I don't remember exactly when I bought it. I think it's given me about like a good 6 years of loyal honest service. And people have said, like, open it and test the cable, do this, that, and the other. And here's... I know this is legitimately stupid. Like, I'm not even going to... criticize you for telling me I'm stupid for saying this, but I hate fixing tools. I really do. Like, I know it sounds silly, but I would rather just pay more money to get all the stuff on my desk to actually work than have to think about fixing tools. Because I have a certain amount of brain power in my day and patience that I can put towards figuring this stuff out, and I really don't like wasting it on something that has just no return. Like, I fixed a hack or what? I can't. Nobody's going to pay me for that. So replacing the element I put off for a decent amount of time, but yeah. I hate fixing tools. I really do. Because then if you fix the tool and you fuck up fixing the tool, then you wasted time and it doesn't work, and it's never going to work the way it used to. And I have, honestly, it really comes down to luck. I mean, I have just such bad luck when it comes to repairing my own tools. It's awful. It's a joke. Anyway, so the diode mode measurement is what I want it to be. And I have a light. I obviously got to cover the username because, as I've learned, you guys really like to stalk people when I leave names up there. So there, you have a light. Shining apple. The apple is shining, but I can't show you because there's a label back there and that this camera is zoomed in a little too good. So you'll see it. But yeah, that's that. So diode mode measurements make it really, really easy to get an idea of what's wrong, what's going on, and what to do to fix it. Again, if my diode mode measurement there was 0.544, I probably would have looked somewhere but the LP8550. Maybe I would have looked for the enable circuitry. Maybe I would have looked for the PWM signal missing. But when you know what to look for, and when you have these measurements in your head for all the different circuits, it makes it easy. Is this chip pulling this down? Is that chip pulling this down? Is this line missing? Is that line missing? Diode mode measurements. Get a good multimeter. Get a nice multimeter. If you want to be able to have measurements that are close to mine, you can get a Fluke 15B. Expect to pay about $100 for it. Get the fine probes for an extra $15 or $30 on Amazon to put on them. I don't have the model number in front of me, and I know everybody's going to ask, and I'm going to forget to put it here. But you'll find, if you just find these fine tip probes, see if these have a number on them. Of course they don't. Why would you put a number on it when it would make it useful for reordering? But yeah, makes it a lot easier. Some people have soldered needles onto it. That just sounds like torture when you can buy that crap for $15. But yeah, that's it for today. So board was dead. Board had no backlight. Board has backlight. I talked a little bit about how I did the estimate, how I figured out. I talked a little bit about how I determined that the chip was the problem, how I used measurements to determine that the chip was the problem. You saw me solder it. You saw the improper way to solder it. You saw what you're most likely doing if you have a $50 hot air station, and then you saw what's going to happen when you have a good hot air station. Again, the thing is, even when it wasn't melting the chip on properly, one of the things you probably noticed is that it was melting solder. The components around the chip were actually getting hot. You could see that they were liquidous, but the chip itself was not. And that's the thing with bad tools. That's the thing about when tools don't work, because you're going to think it's you. You're going to think it's your method. You're not going to think that it's the shitty tool. Because, again, it was slow roasting everything, and that's not what you want. You don't want hot air to slow roast things. You want hot air to be like this little fucking flamethrower, where in this specific spot, you're just like owning it with heat. Like, I usually have things set to really high heat, and I just control it with my hands. Like, I don't control temperature by going in the iron and going, I want 740 degrees now instead of 650 degrees now. No, I do this. Oh, I want 650. Oh, I want 750. Oh, I want 800. Like, it's just how close are you to the board? And you get this feel for your tools when you have a good tool and you know exactly what the temperature is supposed to be. So that, again, that's how I know when it's soldered. When I see it, when it moves in a place, that's great. Then when it moves in a place, I go closer and then I move it around. And then when I see that the chip is dancing, I know that it's liquidous. And I want it to be liquidous for a few seconds so that every single ball melts. And then I'm happy.